Okay, so the questions are. I'm gonna explain Charlotte's solution, um, and then maybe Charlotte will continue from a point where I'm kind of less detailed. So it's a kind of a nice question, right? It's a very basic question. You have two circles which are tangent like this, right? And one of the circles is radius 6, the other circle is radius 24. Okay, and the question is if you draw the tangent line at the point of the tangent, and you draw these two other tangent lines, what's the area of this triangle at the tip? Yeah, okay. And yeah, I guess so. We need to do some calculations. So, so Charlotte's solution started with this, which after seeing that, I claimed it was already solved, but I think um, you might need to know a few more things for that to be solved. But let's just see how this works. Okay, so if if this is 6 and this is 6, um, and these are 90 degrees, yeah, we can draw. We can complete the rectangle here, yeah. We'll complete the rectangle there. Um, we get that. So the claim is this length is 24. Okay. Okay, and the way that Charlotte got it was by drawing a rectangle, yeah. And with that rectangle, you have this is 18 because it's the leftovers of 24 minus 6. This is a rectangle.
Oh, that rectangle.
There's no other rectangle.
Okay, so that's 18, and then we know the radii add up to 30, right? And so by Pythagoras, so you don't actually have to do full Pythagoras. You know it's a 3, 4, 5 triangle times 6, yeah?
Oh, that's actually.
There's 24.
So that's 4 times 6, yeah? Then you get 24. Okay, so she'll explain how she did the rest, but I'll explain why I think that's done based on theory in the next section. Okay, so what did you do next?
Have we figured out all the lengths?
So we figured out this was 24, yeah?
Yeah.
Okay, then what did you do next?
And then the small triangle at the end.
Yeah.
Like, that's a similar triangle to the one that we just did because they have the same angles. And so that would be a 3, 4, 5 triangle as well.
Okay, so you're saying this triangle here, yeah, is similar to this triangle here, right?
Yeah.
Oh yeah, it is.
And so the
Yeah. So and then this line, I guess you can say, goes through both centers because it's it's like a line of symmetry, right?
Yeah. And then
Okay, so this is another 3, 4, 5 triangle, right?
yeah. So the hypotenuse is 10 and the other line is 8.
This is 10 and 8, yeah?
And then the bigger triangle, which is half of the triangle that we're trying to find, also has the same angle.
Okay, so the bigger triangle.
Yeah.
Like the half of the triangle we're trying to find.
Oh, okay. So you're talking about now this triangle. This triangle.
Yeah. Yeah, it also has the same angles, so it's also a similar triangle. And so it's also 3, 4, 5.
It's also a 3, 4, 5. Okay.
Yeah, and we know the middle line where it's touching both sides.
Mm-hmm.
That is 16 because we already figured out a section of it was 10 and the other section is 6 because it's the radii of the.
Oh, very good. That's a very nice solution, I think.
I understand it. That's how.
So then
that whole line would be 16.
16, right?
Yeah. And so.
Well. Okay. So that 16 is the It's not the hypotenuse. It's the
second smallest line.
it's the force. It's the side that's divisible by 4, right?
Yeah, and
And
so
that side is
it's the 3, 4, 5 triangle scaled out by 4.
Okay.
So that's four, that's
So it's
24.
20 and that's 12, right?
So that-
Yeah, and because that line is 12, and we know that the height of the right angle triangle, which is like that line which is perpendicular to that 12, is 16. It's one triangle would be 16 times 12 divided by 2, but this chooses just 16 times 12.
Oh, okay. So this is half the area, right?
Yeah.
So you just got to double this to get the area, yeah? So the area then is 16 times 12,
Yeah,
which is
192.
100.
160 plus 32, yeah. Okay. Yeah, that's very good. So this proves, okay, like no matter how much like this question is almost like a textbook question in terms of like the theory, but no matter how like textbook or theory it is, you can always do it without knowing any of it, right? That's the beauty of maths. That's why maths is so fair in a sense, okay? So this proves that you can solve the problem essentially without knowing anything, right? We consider Pythagoras to be but nothing.
I think it's even very good.
Yeah.
Look, it's a fish.
Okay, so before we go on dinner break, let me try to make some comments about the theory.